So for your unit exam. Oh, yes. Okay. So we'll start right at the beginning of this unit. The first thing we went over in this unit was structure and history of the atom. The history part is far less important than the structure part. That said, there are a couple of multiple choice questions about important people, okay, and about models. So I would go through my notes and just be able to recognize the models of the atom that we talked about. The solid sphere, plum pudding, Rutherford's model, okay, maybe Bohr's model, the planetary model, and then obviously the electron cloud, because that's the most important one for us, okay? So there's a couple of questions in the multiple choice. As long as you can recognize it, that's the level you need to study it at, enough to recognize it as the correct answer, okay? You're not going to need to write out a bunch of stuff about Bohr or de Broglie or anything like that, okay? So yeah, that's what we got from the first one, structure and history of the atom, okay, currently accepted model, right? And how do we get the number of protons, neutrons, and electrons? Why is that important? Is it question number 4 or 5? In the written response, you must draw an atom of my choice. I don't remember what element I choose now, but, okay, did I just say choose?
Oh, yeah.
Where's my cup? I don't remember what element I chose. Okay, but you will have to draw a picture of an atom. That atom must, or that picture, must be of our currently accepted model. And it must have the correct number of protons, neutrons, and electrons, and they must all be in the right places. It'll be a 5-mark question. Okay, you'll get 1 mark for the right number of protons, 1 mark for the right number of electrons, 1 mark for the right number of neutrons, okay, 1 mark for having them all in the right place, 1 mark for being the right model. 5 marks.
Can we draw one right now, just as like a refresher?
That was my plan. Okay. All right, so how do we figure out the number of protons? Atomic number. Okay, so we just look at that. So if this was helium, pick an easy one. Okay, if this was helium, all right, it would have how many protons? 2. Okay, where would they go? In the nucleus, because that's where protons go. Okay, how many neutrons would it have?
Atomic mass minus atomic number.
Atomic mass minus atomic number. For helium, that's 4 minus 2. How many neutrons? 2. All right, where do they go? In the nucleus. Okay, how many electrons are there? 2, because it's always the same as the number of protons, because it has to balance the charges. Okay, where do they go?
Outside the cloud.
In the cloud, right, because the electron cloud is the currently accepted model of the atom. So draw a cloud and put 2 electrons in it. Okay, my suggestion would be maybe you also should have a legend, okay, beside your diagram, so that I don't see this. How do I know if you know where the protons and neutrons are if you don't label them? Okay, so make sure you maybe have, I would maybe use circles for everything, maybe just use like dashes for electrons instead of circles, and maybe put positives inside the protons or something. Okay. It doesn't have to be complex, but just make sure that you differentiate between the different particles. That's, believe it or not, the most common mistake people make on that question. Okay. It's just drawing a whole bunch of circles. Okay. All right. Naming and writing proper chemical formulae. I cannot stress how important that is. There are a couple of multiple choice questions about that, but that's not why it's critically important. Being able to write the right name and the right chemical formula is critically important for both predicting the products of a reaction, writing a reaction properly, and doing mole equation calculations. Okay? You've got to be able to drop and swap an ionic compound or write the formula for a molecular compound. It is just crazy that you can do that. Okay? That was what we did the second day of the unit. Okay? Things that people forget. When to use a Roman numeral, or what it means when they have one. What does it mean?
It's the charge of a multivalent.
It is the charge of a multivalent. So if I have lead 2 iodide, what do I use the 2 for?
Lead.
Okay? Yes, I use it for lead, but what do I use it for? I use it for the charge in the drop and swap. It tells me use the 2, not the 4. Okay? Which is really important when I want to write the formula for lead 2 iodide. Okay? That's what we use them for. In the reverse, I could give you this formula and ask you to write the name, and then you would have to do that whole working backwards thing, right? Every iodine is a -1. There are 2 iodines, so this lead must be a +2, so I write the Roman numeral 2 in the name. Okay? Got to be able to do that, got to know what those are for. Okay? Special elements. We have to know those. They're on our periodic table, so you don't have to memorize them. You just have to remember what those mean. Okay? They're critically important when predicting or writing chemical reactions. Okay, properties of compounds, lesson 4. Okay, this is important because we did a lab on it. Okay, if we were going to spend the time to do a lab, properties of compounds is important. The way that this will get tested is twofold. There could be some multiple choice questions about that would maybe go something like this. They would ask you to do exactly what you did in the analysis of your properties of compounds lab. So, sounds something like this. You have an unknown compound. It is a red crystalline solid that is highly soluble in water, whose solution conducts electricity very well, and has a pH of 6. It is A, hydrogen chloride, B, diphosphorus tetraoxide, C, cobalt 2 bromide, D, nickel 2 nitrate. Which one would it be?
Cobalt.
Cobalt. But whatever it was with, I was making everything up right now. But okay, yeah, it would be the one that contains cobalt, because cobalt-containing compounds are ionic, so they would be crystalline solids. Cobalt-containing compounds are red, they would be highly soluble in water, conduct electricity, all of that stuff. That's what you'd be expected to do. So go over lesson 4. There's going to be a few multiple choice questions like that. Okay, there could also be some stuff in the written response that might ask you kind of some stuff about properties and solubility. All right, solubility. You need to know your terms for a couple of reasons. I will use the same terminology on the test. So if I'm talking about a heterogeneous mixture and you don't know what that means, I don't know how you'll get that question right. So you definitely need to know your terms, okay? Or solute and solvent, okay? Precipitate, stuff like that. You need to know what those are, what those mean, so that you understand the question, right? There might be like 1 or 2 multiple choice questions that are strictly like terminology based. If this thing dissolves in water, it is A, soluble, B, a precipitate, D. Like there could be some questions like that, but mostly you need to know those terms because I'm going to use them, okay, in all of the wording that I use. Okay, so you need to know your terminology, but you also need to be able to use your solubility chart. I have a couple of multiple choice questions on the test that are, here's a chemical reaction, which, if any, of the products are soluble? All right, so if you had, like what we were just looking at a minute ago in our lab, okay, where we had NaOH plus MgCl2 gives MgOH2 plus NaCl, okay, I would go to my solubility chart and go, okay, sodium chloride is soluble. So the one that's soluble is sodium chloride. The other one is not, and I'm done that question, but that's the kind of thing you should be asked to do. Okay? Just show me you can use your solubility chart. The other way that I'm going to ask you about solubility is on the last question of the test, in the written response. I'm going to ask you to apply to a new or novel situation what you know about solubility and replacement reactions, like this. Okay, this is a replacement reaction that produces a precipitate. Okay. If I was trying to remove something from a solution, could I use a reaction like this to get rid of it? If it was already dissolved in water, right, and I wanted to get it out of the solution, could I use a reaction like this to do it? Probably. That's something you might want to think about over the weekend. All right, so that question is the one that's going to make you think the most. Okay, I always put a question like that on a test because that's kind of the separate the wheat from the chaff kind of a question. Okay.
So like explain to someone what solubility is kind of thing?
No, not explain what it is, because that I can use a multiple choice question for. This is going to be show me not only what you know, but how you can apply it to a situation you've never dealt with before. Okay? This is the highest level of thinking that I can ask you to do. Okay? I have to, and it's, a lot of people say, well, it's not fair, you never taught us that. I can't teach you everything, nor should I try. Okay? But what I'm asking is, take what I taught you and show me how well you understand it by applying it to a situation you haven't seen before.
Talk about the whole test. Like, how much would you say is multiple choice and how much would you say is like?
I'll get to that.
Okay.
Yeah. Okay. Polar nature of water. Definitely need to know about that. Okay? Need to know about hydrogen bonding, cohesion, adhesion, okay, that kind of stuff. There is a written response item all about what it is to be a polar molecule and what that means. Basically, it's read and regurgitate what I put in lesson 8 about water and a polar molecule. Okay, so study that. Okay, be able to tell me what a polar molecule is, why it behaves the way it does, okay, and some examples of where we might see that in nature. So like I said, read and regurgitate the last half of lesson 8. Okay? Okay, so what is a polar molecule? Know about cohesion and adhesion, that's hydrogen bonding, real world examples. Okay? We went over a couple, okay, that day. Okay. Reactions. It's more than half your test in terms of marks. Okay? More than half of the test is about reactions. Being able to identify the types. There's a couple multiple choice questions where it's like, which of the following reactions is a decomposition reaction, A, B, C, or D? Okay, just simply recall. All right? But question number 1 in the written response, 7 reactions to balance. Okay, just balance. That's it. Fill in the blanks, balance. Question number 2. 4 reactions. Predict the products in balance. I'll check that again. I'm pretty sure that's what it is. Okay? So those skills that we went over that are on that assignment you handed in to me today, huge marks. Okay, between those 2 questions, 23 out of 80 marks. Okay, it's huge. It's huge. It's almost half of the written response marks, 2 questions. All right. Writing reactions, balancing reactions, okay? All those skills that we went over, okay? Absolutely huge that you are able to do those things. Okay? Mole equations. Mole equation calculations. One of each type. There's 4. They're not in order. They asked me that yesterday. Do they go in order? You did all the examples you did in order. No, they don't go in order. Okay? Okay, and then lastly, scientific method. So there's a couple of multiple choice questions that would go something like this. In an experiment to test the effect of light on plant growth, an experimenter designs an experiment where 8 plants are put in light boxes. The plants all get different amounts of sunlight, but the plants are all identical. They all get the same amount of water. They're growing in the same soil. They're growing from the same length of time, blah, blah, blah. Lots of things are kept the same. Okay? Over the course of 6 weeks, the experimenter measures the growth of the plants by taking their mass and measuring their height. What is the manipulated variable in this experiment?
Amount of light.
The amount of light. Okay? That's a scientific method question. It's basically asking, can you identify which variables are which if someone talks to you about an experiment? Okay?
So scientific method is basically like, what is this part of the like lab or whatever kind
Yeah.
of thing? Okay.
Yeah, exactly. That's what's on there. Okay? Now, even more specific. Okay, there are 33 multiple choice questions. In the multiple choice, I am going to ask you about things like physical and chemical change, physical and chemical properties. Scientific method questions like we just mentioned there. Properties of compounds. Solubility. Atomic history and structure. Naming and writing chemical formulas. Identifying reaction types. That's it. That's what's in there. Okay? There's 33 questions. There's quite a few on naming, quite a few on solubility. All right. In the written response, there are 6 written response questions. Question number 1 in the written response, as I already told you, is 7 reactions that just need to be balanced. They're 1 mark each. Okay, and then question number 2 is, as I said, it's 4 reactions that must be identified, predicted, and balanced. And they are 4 marks each. Okay, so you get 1 mark for the reaction type, okay? 1 mark for the reactants, 1 mark for the products, 1 mark for it being balanced correctly. Question number 3 is drawing a picture of an atom. 5 marks. Okay, we talked about that one already. Okay, question number 4 is your mole equation. Okay, 4 questions, so there's 1 of each type. Question number 5 is your polar nature of water. It's 5 marks. Question number 6 is the question I was telling you about that has to do with solubility, replacement reactions, in a situation that's new. And it's out of 4 marks. Okay, so the whole test is out of 84. Okay, to give you an idea, in the written response, as I said, there's 51 marks. 27 of them are reactions. Fourteen of them are mole equation. So, if you're really trying to figure out what do I need to spend lots of time on, no, I'm just putting it out there. It's 41 of 51 marks. Maybe those 2 things. And that's not even including the multiple choice where there's more stuff about, reactions and things like that. Okay. All right. How do you go about studying for this test? I can tell you a few things to do, give you a few recommendations, but in the end, everybody is a bit different on how they prepare for a test, and you kind of have to figure that part out for yourself, okay? But what I will tell you is that for a subject like chemistry, where much of what is being assessed is skill related, practice your skills, okay? And what I mean by your skills would be being able to identify reaction types, being able to balance a reaction, predict the products, write it out, okay? Be able to name and write chemical formulas, that stuff. Those are your skills, okay? You gotta be able to do those things, right? Do you need to read over your notes? Yeah, a couple of times. You know now, I've kind of told you what things are gonna be important out of your notes. So do you need to read over every single word of your notes again? No. Do you need to focus on the things I've told you are important? Yes. Okay? Chemistry is not a science where it's a lot of reading and memorizing. Right? Certainly go over your notes. You know you need to go over properties of compounds. You need to go over the stuff about the polar nature of water and maybe know the models of the atom. Okay? But do you need to go over every little thing? No. Okay? Don't spend your time highlighting and and reading and reading and rereading. That's not how you study for chemistry. Okay? It's worth it to go over and make a few notes on the important things, but that's it. Okay? This is mostly about being able to practice and then demonstrate your skills. Okay? And that's what you need to focus on. Okay? Now, I did post in Google Classroom the other day, okay, the review package. All right, so I'm just going to have you have a quick look at that here. Okay, so it's right there. Unit 1, chemistry exam review package. There's a key, and this is the key here, and then this is just the review package itself. Right, you're going to have the recording as well of what I just did today, because I'll post that. Okay. It's got a few things that it recommends that you do. Okay, draw and describe the atomic models. Okay, you know, there's reactions here for you to write out and predict. There's some mole equation questions there for you to try. Okay, there's some kind of like those wheat from the chaff questions, like question number 6. There's some examples of those here, and then there's a practice test. Okay, these questions have all been on previous versions of my chemistry unit exam. Some of them may still be on my chemistry unit exam with very small changes. Okay, what I'm going to tell you guys is this. My chemistry unit exam has the same skeleton as this. The bones are the same, the tissue is different. Okay? All right, so here's a question about chemical change. I told you the physical and chemical changes on your unit exam, so there's a question about it. Okay, it's going to give you a pretty good idea of how I'm going to word things, what it's going to look like. Okay, this only has 25 questions. Yours obviously has 33. And then look, oh my gosh, it's just like what I told you the test would be like. There's some balancing questions. Okay, there's some predicting questions. There's a draw a picture of an atom. There's a mole equation. There's some stuff about how our knowledge of the atom has changed, and there's a question about solubility. Might be worth looking over. Okay? All right, that's my recommendation for you. Okay? My recommendation is also don't spend your whole weekend doing this. That's not healthy. Okay? You need to take breaks, and you need to eat turkey. And unless you're vegetarian, then you can eat tofu. Tofu. It's a thing.
Is it actually?
Yes,
That's
tofu.
disgusting.
Apparently it's like turkey flavored tofu.
So
Yeah.
That's
But it's up to you. You gotta make those choices for yourself. For me, I like the idea of the turducken because it's 3 different animals that I get to eat all at once. But yeah, that's just me.
I like the stuffing. That's my favorite part.
Stuffing is awesome.
And the gravy.
And the gravy. Oh yeah, the potatoes and gravy. Yeah. Okay. So, guys, you'll be back here. You'll be back here on Wednesday. Okay, because obviously you get Monday and Tuesday off. Okay, but back here on Wednesday. On Wednesday will be our last day of this unit. It's all about mole equations, so if you're still struggling with that, okay, we're going to go over that. But also we can use the last half of Wednesday's class to answer any questions you might have after doing all of your review and studying. Notice that I am implying there that you're not waiting until Wednesday night to study for this test. If that's your plan, you have time to change your plan. And you should change your plan. Okay? One night of cramming does not equal exam preparation. It equals high chance of failure. Right? Study in little bits. You're much more likely to retain that in your memory than trying to cram all night. Okay?